Okay, this is part 2 of the tracker, how to use tracker to determine the acceleration of a trolley going across the screen. So previously to this we tracked our trolley going across, and we've gathered some data here which we've copied, right click copy, and we're going to put that into an Excel spreadsheet. Here's one I prepared earlier. So I guess the first thing we do, we can open a new sheet. So we've opened a new sheet and we're going to copy our data to somewhere on our spreadsheet. So we've got 1.5 seconds of data, and you can label your columns if you wish. Time is in seconds, and it's increasing every 0.1 of a second. X, the values there are actually in meters. Okay, so what we want to do with this data is we want to create a velocity time graph, and therefore we need to calculate the velocity and put it in this column here. We know that the velocity, so I might label that column first of all. The velocity will be in meters per second, right? And we know that the velocity is the time, the velocity formula is the change in displacement over the change in time. So between each change in displacement, we want to calculate the change in displacement between these 2 points here and divide it by the change in time between these 2 points here. Okay, so we need to insert a function into this cell, and the function will be, for any function or any formula that you use on an Excel spreadsheet, it needs to begin with equals. So we need to take cell B5, so I've selected B5, and I'll put this in brackets because we're going to divide the velocity versus time. So B5 minus B4, oops, right, divided by the change in time, which is 0.2 minus 0.1. So when I select it, it actually selects A5 minus A4. And a little shortcut that Excel does, I can just put in A4. Now I'll need to insert brackets, and what that will calculate for us is the the velocity at that time interval. Now when I select this corner of the cell there, you'll see a cross appears. I can copy that function down to make it correspond to this data, or to all of this data going down. So basically I've applied that formula to every one of these cells going downwards. What you can see from this data here is that up to about from here to here, you can see that something's funny has happened here, but
could I start, please?
So as you can see, it's calculated the velocity of each set of data. So it's taken that cell minus that cell divided by that cell minus that cell. That's the change in velocity at each time interval, between the last time interval, from this time interval compared to the last time interval. Okay, now we're ready to actually plot I might leave out that last bit of data there. We're ready to plot a velocity versus time graph. So what I'm going to do, I'm going to insert a scatter chart, and it's actually given us more information than we want. It's actually given us the X, the displacement against time, and I don't really want that, so I'm going to right click, I'm going to click on that data and just press delete. Now all I've got is the velocity against the time, and what I need to do next, in order to form a line of best fit, I can select that data there and right click and add a trend line. It will give us some options for adding a trend line. It will give you a linear trend, which we know it is going to be a linear graph because it's constant acceleration. We know it's constant acceleration because it was the one force dragging it down, and we know that if it's constant acceleration, the velocity versus time graph should be straight. The other thing that we can get from Excel is we can get it to display the equation on the chart. Because it's a linear graph, the equation of that graph is y equals mx plus b. So if I close that, I'll be able to see it provides the formula for our graph. So the y-intercept there is 0.0245, so it's nearly on the origin. We've done a pretty good job with our plotting or our tracking, and the m in y equals mx plus b is gradient. So here we know that that gradient there is going to be equal to the velocity divided by the time. So the gradient is going to be our acceleration. So right now we're basically at the end. We've figured it out that our acceleration is 0.135. We might leave it to 3 decimal places. That's quite accurate anyway. Meters per second, which is the same as meters per second squared, and that's it. That's how you would work out the acceleration from a displacement versus time graph and then a velocity versus time graph. Thanks for listening.